Hi, let's start off with acid-base calculation. With that, we have 4 sets of formula. To show you, the first set is actually a generic set of formula that's always used for acid and base. And this is actually also the first set that will only be used for the calculation of strong acid, strong base. So for these calculations itself, the first thing we want to introduce is what is pH. Actually, when they say pH, the small p represents negative log base 10. So technically, you can P on anything, which means you can have your pOH, which is equal to negative log base 10 of OH minus. You can have your pH, negative log of your H plus. You can also have your pKa, which later, or pK, any equilibrium value, which is negative log base 10 of the value of your K. So in short, chemists use tends to look at px, because if the numbers itself is very small, if they prefer to work with a positive number, then they will do a negative log base 10 on that number. All right, okay. So that's the definitions of the first part of what is pH, pOH, and pK, pKw. Later you will come across that. So with that, we look at next the hydrolysis of water. All right. In the ionization of water, you will produce H3O plus and OH minus. So using the equilibrium constant Kw, all right, you will find that it's expressed in this manner. And that is actually 10 to the power minus 14 mole squared dm minus 6 at a temperature of 298 Kelvin. So what this really means is that when we actually say the pH of water is 7, all right? So we say the pH of water is 7, it actually implies that the concentration of the H plus that we are talking about is 10 to the power minus 7 mole per dm cube, all right? And using the formula on top, you would also realize the concentration of OH minus is also 10 to the power minus 7 mole per dm cube. And in fact, one of the important principles to understand when we say that certain solution is neutral, it actually means the concentration of H plus and OH minus are equal. And when we say, so in this case, like in the as exemplified in the calculation that we have done for the case of water, right? All right, let's try and take a look if, say, we now make a change. So when these two concentrations are equal, they are neutral. So if we change, we say, let's take a look at say the pH of a solution 1, all right? Of course, this could be our hydrochloric acid. So in that context, if pH is 1, con H plus would have been 10 to the power minus 1 mole per dm cube, and which means your concentration of OH minus is 10 to the power of minus 13. So what this means is that this solution is an acid because the concentration of H plus is higher than OH minus, all right? Finally, let's take a look at the last example. When we say the pH of sodium hydroxide in alkaline solution is 13. So in this case, the H plus is 10 to the power minus 13, while your concentration of OH minus is 10 to the power of minus 1. And we can see that the concentration of OH minus is significantly higher than H plus. Therefore, the solution is actually deemed to be alkaline. So the formula that we introduced down here, we term that as box 1, all right? And this box 1, as I've said, is used to calculate basically pH and OH generic as a formula. But more importantly, box 1 is the only set of formula that you will use to calculate the pH of strong acid and strong base. Thank you.